Ay, 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 update titles, learning, it's Atari assembly. I'm just so bad at this stuff. There we go. I wrote down Nix again because guess I was just setting up the wrong thing. Let me just make sure that I have it correct now. Yep, it says Atari Assembly on Twitch, and let's go check out YouTube. Atari Assembly, yay, we're working. There we go. Under entertainment category, it sort of is entertainment. I don't know how to change that. Edit title and description. Yeah, I can't change where it is. Oh well. How are you all? Are you all? Oh wow. Hey Blocks Hub Roblox. How you doing? Hello, hello. Oh my. Are you guys here already? How, like, I'm barely here. You guys are faster than me. How's this possible? And do I have my chat on this time? You can actually hear me, right? Okay, cool. Hey, Findus. Hey, Unlink. Oh my god, all these people. Joaquin. Awesome. So I think we're going to do Atari today. Hope you guys didn't see the Nix thing and be like, I want Nix. That was earlier. Not today, but I just published a Nix thing. That was a video excerpt from my conversation with Isabel. That was really fun. I want to do more like things with Isabel and other fun people. But I'm so out of steam today. So like I'm playing around with all these languages and stuff, and it gets like I do this normally, right? But since I've started streaming, it's a little tricky because like I normally just forget everything, right? So like when I want to do assembly programming again, I have to go back. Oh no, Pico, I'm so sorry you got conned. Oh, actually, that reminds me what you said last time. I will open up our Discord channel and I will look in. I don't know. I guess I'll make a channel called like stream under general. And if you want to type there instead, you can. And it's under general chat. And at least that way, like, there won't be the lag that you were experiencing last time. I'll try to keep this up over here so I can see. It's going to be hard. There's too many things on my screen. Did I read about Encore? What's Encore? I forgot. Do you have a link? What is it? Backend framework for type-safe distributed systems. Is that it? Let me see if I can bring that up. Something like this. I did not look at this if this is what you're talking about. Oh, that's cool. Rust powered performance and type safety in Node.js. So what? Is this better than using like TypeScript? I don't understand. Open source TypeScript backend framework. Oh, I see. It's a backend framework. That's pretty neat, but like I think for me, I would kind of prefer functional languages if I was going to do backend work, which I mostly do. And so I generally use like I would use Elixir or Gleam or something like that for the backend work. Or yeah, maybe. Looks pretty cool though. I think that's good. All right, but let us do some Atari stuff. So what I was saying was I forget everything, right? So I need to basically remind myself, but I haven't been doing that as much with you guys because I feel like, wow, that's terrible content, right? Just like redoing the same stuff, the same shit over and over. But it's just how you learn. So, I'm making this content really so I can learn. So hopefully, that's just how the sausage gets made, I guess. You gotta like suffer. So what I was thinking was this last chapter, where was it? This last chapter, we talked about, it's not this chapter, it was this previous chapter. We talked about assembly language programming with branches and loops. Where is it? Yeah, here. Oh, wow. It's a lot of pages we did, huh? Chapter 7, looping and branching out. I'm not going to read it again. I just want to try to write the program that we ended up with at the end because that's how I will actually like remember how to code this stuff. Because assembly language programming isn't all that obvious, right? So for anyone new, this is, hey Pico, I see you. All right. Maybe I should turn on Discord alerts so that I can hear the sound. I'll move it to this. All right, can you type in a message, Pico, in stream chat, and then I'll see if I can hear it. All right, so what was I saying? I am so ADHD brain today. So I'm going to try to type in this program. Yep, I heard it. Awesome. So everyone else is going to hear it. Hope you guys don't mind, but at least I'll know. I want to join Discord. Where's the link? Let me send the link. It's in all my other videos, but I'll update it in the description. 1 second. Info. Here's the link. And in chat, I just put in chat. Does that work? I think it worked. If it didn't work, let me know. I feel you there. I often go to writing 8-bit code after work and it's like a jarring whiplash. Oh man. Yeah, it's like totally different, right? It's like a different world. Now, how come I didn't see that message? Oh, I just missed it. I just not very good at seeing messages. All right, so let's do this. Let's get started. We're going to be coding 6502 Atari assembly, and there I heard it again. Oh my. How do most streamers handle this? I know a few stream on Twitch and YouTube, etc. From Pico. Yeah, I don't know. There's always lag, right? You just don't notice it when there's a million people typing. You ever watch like the streamers like, what's his name? Primogen or something? Like there's like a billion people watching and it's just streaming and like he's replying to people that may have typed something like 3 minutes ago. Who knows? Oh, hey there. Hey there, Blocks Hub. Now I need to like put this stuff on chat too. So let's go. I'll eventually get there. So here we are. We're going to write some new code. Remember what we're trying to do is basically they gave us like a little piece of code that knows how to take some characters that are in memory and print it on the screen. So our job is to put the characters there. So that's what our program is going to do. Let's start writing it, I guess. So here we go. We'll start at 100. And I think usually we want to just say something like opt-obj. God, this feels like a million years ago. And we want to also say where we are starting in the memory. And I think for us, we're doing 600. And then let's give it the program name. So here we are, what program are we? We're doing like, let's do the response program where we say something like, what was it? Was it like, I'm the leader, stupid, or something like that? So we'll call it response. And then we need a bunch of bytes, right? So here's a compiler directive called byte. And I think after byte, we can just give it a string, right? You can give it like hexadecimal characters, like, you know, whatever with comma separated, but that we also learned that we can just say within quotes. I think it's double quotes. I can't remember. I am the leader, dummy. And then we needed to give it the EOL character. So I think we just say EOL. Do I need $sign EOL? No, because EOL is going to be, we need to have an EOL. So we need some constants in here. Let's put that in 205. So EOL is going to be, was it like hexadecimal 60? I want to say. We'll look at the actual program later. I think that is the carriage return in ASCII. What else do we got to do? We need that text buff. We need that memory location in text buff so that we know where to copy the code into. I think I wrote down where text buff was supposed to go. That is 504, whoops, I can't type it, 5041. And then we also need to call the open screen subroutine from our like other program, and that is in memory address 5003. And then we have to actually do the print screen, which takes the stuff, print line, I think it's called. And that I wrote down is 5031. When you take a break, could I ask for a 10,000-foot overview? How did you get into Atari assembly? I can answer that now, sort of. I didn't get into it. I just am in it now. I don't know. Okay, but I'll answer for real. I think that's what we need. So this will give us like the 3 memory addresses that we need to deal with. EOL is wrong. No, because EOL shouldn't be just, it's a literal number. Why doesn't it not need a hash? Shouldn't it be $#60? I don't think so, because when we type bytes, oh, that's right, because there's an exception for bytes. It just basically assumes everything is direct anyway for bytes. So since we're using it in byte here, it's automatically that. It's automatically immediate mode. Okay, so I think I have all of that in there. Now what do we have to do? We got to set up, we got to do a little bit of setup, right? So our general setup is something like, where were we at? 310. By the way, I figured out how to go up and down. Remember last time I couldn't figure out how to go up and down? Watch this. Whoa! Whoa! Does this look crazy or what? The key there is, and I put it in the gist, the Atari gist file I have, is that in Altera you have to press Alt and arrow buttons, at least for me, right? So that's why it's doing that. What else do we got going on? Now we need to set up the stuff, right? So I think we gotta, like, I don't think we need to clear the decimal mode but we can do it just because we like to do that sort of thing, right? No, we got to set a, you see how we have this byte code stuff? So address 600 is where the byte stuff is going to be. We need like another comment for where the code actually begins. Oh, we already have that. We have response. So I think it'll tell us where response is in memory because that's where we start execution of our code, right? All right, so there we go. There's our code so far. Let's go. 320. We're going to clear decimal mode. And 330, we're going to clear the carry just in case, clear carry. And now we can start our code, which will, oh, we need to load the incrementer. So we're going to use the X register to basically copy stuff from our byte buffer to the text buffer. So we need to set that with 0. So I think that is like load X $0. I think that's what it is. And now we can loop. So how do we loop? The idea of the loop is that we copy the stuff from text buff into the accumulator. Then we compare the accumulator with, then we store it into the text. No, we copy stuff from the byte area, this byte area, and then we copy it into text buff. All right, let's just try this out. So we'll say loop, and that was the label for it. Now I need to copy. How do I refer to the stuff in byte? So I think I need to do load accumulator, right? With an address of this byte thing. How do I know the byte address? Jesus Christ. It must be 600, right? Because that's where we start in memory. Because this doesn't take up anything. So I think we do 600 here. Memory address 600. We load that into the accumulator offset by X. God, this is so much harder than the last time we did this. Oh, someone typed something in general. Oh yeah, these are just people joining. Hey everyone who's joining Discord. This is so much harder. I'm like such a noob. All right, now that we've loaded it, we can compare it. Do we store it first or do we compare it? I think we store it. We store the stuff into text buff offset by X. I'm just worried about the +1 error here. What if we go too far? Maybe we need to copy the EOL, right? And then we compare. Is there a link to this doc? I like this. Might try to catch up. To this document, you see this book. Any of my, just go to my playlist for Atari, and it had all the videos in there have a link to this book, but not to the files because they're in my 8-bit machine. I don't know how to get it out. I guess we'll learn how to get it out at some point, right? Like, we can probably pull it out of the disk file. I can probably send you the disk file, but like you should type this in. That's how you learn. Okay, so we're going to compare the stuff that we have in the accumulator. This CMP is going to compare with the accumulator and subtract that with EOL. So we're going to do EOL here, you see? I think that's how we say it. I'm doing this a lot. I think that's how it goes. And now, if it's branch if equal, which means if the 0 bit is set, that means they're equal because it subtracted the number from itself, and then it would be 0. The 0 bit is set, and that's what BEQ is actually checking for. Is the 0 bit set in the program status, process status register? So if it's set, then we're done. We're going to need something called fini. Otherwise, we increment, what is it? In X, I think, right? That increments the X counter. And then we're going to jump to loop. God, this feels all like I'm just totally guessing. All right, and now we need to add fini. So here's what happens when we're finished. I think we just do a tight loop when we're finished. So we just do jump fini. Now I get noise for whenever someone DMs me. Now I'm distracted. All right. I think that's the code. So let's save this code. Let's look at it. Oh, we need like, no, we don't really need an end, but we can add an end. I don't know if we need it, but we'll add an end. No, we're not going to add an end. We're just going to save this. So saving is enter or list. No, almost made a mistake. It's list. D2, and we'll call this like, I'll call this try one. I have to write it down because I forget. Try one dot source, right? Because I'm sure this can't be right. And now let's try to assemble it and see what happens. Guys, that can't be good, right? Like that literally can't be good. I've never seen anything like that. Let's restart here. Hard restart. Max 65. I've never seen it like halfway through assembling. It's like I'm fucked. I can't do anymore. What the hell was that? Enter D2 try one dot source. Why did it die? Isn't it, aren't I supposed, was it $600? No? Or is it, do we usually write 600? That seems maybe better, no? Let's see if that compiles any better. Look at that. Yeah, I should set notifications for just this channel, but like, I've never had to do that before. Let me see. Notifications, all messages, only, all channels. I don't know how to like just be like, no, the problem is I have all my other notifications and DMs set up, right? So it's kind of making noise all the time, which is kind of annoying. Pico sent a message. Anyway, it assembled. Holy shit. Let's do that again, just so that I can see. Because remember, we learned we can press F8 while it's printing, and we can kind of see what's going on here. So notice here it's turning everything into the assembly code here. So we see that the bytes start in address 600, which is what we want. and all of this are the hexadecimal codes for I am the leader. So probably I is 49. So we start at 600. The loop starts at 61B. Do we need to know that? I don't think so. And then the last line is, we'll write the last line. It's, oh, we do have to know when to, when it starts executing. So I should look at that again. 1 second. Let's do it one more time. Because when we run the program, we need to start here, CLD at 617. So this program starts, the data starts at 600, but the program starts at 617. You see that here? That's the first line. And then it ends at 629. All right, cool. And it prints all of the symbols here. Fini is 629, so that makes that symbol easy to see. Right. So what I should have done is made a symbol for, here, let me actually do it now and it'll be better. Wait, why can't I type in here? Guys. I've lost my key focus for this. Oh, I probably pressed F8. There we go. It was probably like paused. So here, let's just add not a remark, but a label where our code starts. So that would be in 315 or 320. We can just do 320. Try, and it's CLD. So I've changed this to be try CLD, right? Let's save this. And we'll call this try2.source. I'll update my little paper here saying that I made a try2. And now when I assemble this, you see at the very end, I don't need to like pause. I can just look and say, try. We start at 617 and it ends in 629. So I can just have those numbers for when I actually try to debug it. Mute the general one. Yeah, I can mute the general one, mute channel for 1 hour. But people DM me a lot, so it gets a little annoying. Maybe there's a way to just turn off DMs? I don't know. All right, so we have this program running, but we don't know if it works, right? Let us look at the original, you see on my left here, where we're looking at the program for printing the screen. This is where we'll see what the numbers should be. End of line should be 9B, so I had it wrong. Here's the print screen, and here is the open screen routine, OSCR. So those are the addresses, but I think I had that right, but the 9B is wrong. So I need to copy this number instead. Let's do that. So now I'm going to do this fancy thing here and move over here. I think I can just turn this to 9B and press return. Holy crap, let's see if that works. So now when I type list, does it say 9B? Oh, look at that, that's so cool. It's like super archaic editing. It's like NeoVim, but in the Stone Ages. Okay, I never answered Pico's question, so let me save this again. I will just overwrite try2 because we just changed a very small thing. So the question is, how do I get into Atari assembly? And assembly language, like if you know me from my other content or at all, like I'm a very high level language programmer. This assembly stuff is not natural for me. It's my weak spot. I like using Elixir in general. It's my sort of main language. I used to work at a company where I programmed in Scheme. So functional languages, I just love them. I even wrote some networking code recursively just to like, because it's so much easier to think about it, and then I change it to an imperative way. So this is hard for me. All that to say basically that like, it always felt like um, something just really different and foreign to me. I did take an architecture class when I was at university, and I did really well, but it was mostly like designing computers and microcode and stuff like that. Not so much writing assembly. It was like more like designing computers. And I really liked it. I did have to write very little assembly, and it worked. This was like the first time I wrote all this assembly code and I compiled it once and it worked. I was like, I had no errors in my code. I couldn't believe it. And isn't that funny? Like I've never written a high level programming level code that had like hundreds of lines and it works the first time. But the only code I ever wrote where it worked the first time was assembly language. So it was like, oh, holy shit. So anyway, it was always foreign, and like that's one part, right? Assembly language, I don't get it. And there's a certain intrigue to it when you don't know something well, like when something just seems really weird and different. It's like another animal. It's like going to the zoo and seeing like, whatever, a wild tiger in the zoo. I guess it's not wild, but you know what I mean, right? You're just like fascinated by it. You want to see it and like look at it. So I'm kind of fascinated by like assembly language. Like people who write assembly language, they're just like, how do you do it? I don't even know how you think about this and write it. So I wanted to get a little bit more of a feeling for that. The other thing is that I have a part that's just, it's sort of like this nostalgia of something that I never knew. Like I never had an Atari computer. So it's not like I'm reminiscing about Atari computers. I never like all these 8-bit like British computers like the Acorn or the ZX80 or something. I've never had any of those, but I just like there's just something that just seems like when you're watching an old sci-fi film and it like has this old tech, you just want like I want that thing with all the buttons and lights and switches. It just seems kind of cool. So like I guess I just want to know what it's about. Like what did I miss here? The same thing, like, I don't know if you saw that I'm doing a COBOL thing. I never programmed in COBOL on a mainframe, but like, I just want to know what this, like, history of computers. I guess it's like a historic interest in computers. And I could have done, like, the Commodore 64, but the Atari, like, the way they looked and the history of Atari sort of being the first video console, also, sort of. Like, I just wanted to explore that and get to know a little bit about it rather than going down the Commodore route or the British computer routes. Like, I want to try out the ZX80. They used the Zilog chip and, the Z80 chip, basically. But, like, one day, can't do it all at once. And then, oh, the last thing that comes into this is, like, how did you program an 8-bit computer where, like, you had, like, 48K or 64K of memory? Like, it's insane. Like, and you're doing 8-bit math, your numbers only go up to 255. Like, how did you make games with this stuff? So I kind of want to learn just a little bit about like programming with constraints. Maybe this will eventually lead into embedded programming, which has been sort of a back interest of mine. But anyway, it's sort of like these are side hobbies to play around with, I guess, just to explore. So that's it. That's my answer to how did I get into Atari. assembly language programming. I don't even think I'm into it yet. I'm such a noob that I can't consider myself into it. I just barely know enough to like write hello world, right? And barely that at all. So let us continue now. We have to load the loader. We have to load the loader program first, and that was let me do a hard reset so I can make sure that everything happens in order. That program is called print screen2.source, I believe. Yeah. And that's loading it, and now you can see this is the stuff for printing the screen. We'll assemble it. That should have put it in memory. And now we can load our program, which we call try2.source. And we should be able to assemble that. And now we can go into DOS. CP means command processor, which is DOS. And we'll run the bug65 program, which is our debugger. And now to run the program, we give it the starting address, which is 617. Oh crap. That's not right. User run. Something didn't go right. So let's compare our program with what it was supposed to be. Here's our program, and let's see what it should have been. Here it is. Text buffer 5041. Open screen 5003. Print line. Oh, I have this wrong, but oh, I never called these programs. Hold on. I just realized I never call these programs. So we got to edit this and actually call these programs. I'm so silly. So over here, instead of 500 where we end, we actually have to call the program. So what should we call this? Like, I guess we can still call it finished. And then we will jump subroutine to open screen. You guys need to tell me when I make a mistake. Pay attention so you're involved and you fix this stuff for me. Open screen. Open source. I wrote open source, but as long as I keep the same name, it's fine. And then after I open the screen, I can jump subroutine to print line. Oh, I typed everything wrong. It's supposed to be PRNT. Doesn't matter, just has to be consistent. And then after this is done, can we return? Or I think we have to do a tight loop. I'll call it real finish, jump, real finish. I'm not sure if this is how it ends or not, but that's how we're going to end. Okay, so this is basically the end of the loop. Then after we're finished with the loop, everything's set up in memory so that we can call the open screen routine, and then we also call the print line routine. And then after we're done, we just go into a tight loop. So let's save that. No, that's called list. I keep almost screwing myself up. We'll call this try3.source. And we'll try to assemble it. All right. Fini, loop, open screen, print line, try. Try, that's where our loop is. Okay. Did I save this? I don't think, yeah, I just saved it as try 3. Yeah. God, I hope I have no memory. Did I save it? Let's assume I saved it. God, I'm scared now. Yeah, I think I saved it. Let's find out. Now we have to run this whole like compilation path takes a while. It's a little annoying because of the time it takes. Hey David. Trying to figure out what I did wrong. It didn't work. And now I compiled that. Now I need to load my test program, try 3. Okay, let's see if I saved it. Yeah, I saved it. Let's assemble this and let's see if we work this time. Command processor, bug 65. And now we say go, what line number was it? 617. Hey, it worked. Sort of. So it copied the stuff and printed on the screen, but it obviously did not clear the buffer first. So we need to do that, right? Q to quit that. And at least we made progress, right? So let's go back to max 65. And we'll load our program. And here we are, right? We need to write a program that's going to clear the memory at text buff 5041. And I think it was like 40 characters that we were clearing there. So let's do that. We'll make a new part of this code. We'll give it like fill. We'll call it fill. And in fill, what do we do in fill? We're going to use the X. We're going to use the X register to basically copy stuff, right? So I think we want to load it with. There was a way we can do this backwards. We decrement to X, and then we just have to do a simple compare if it's 0, right? Yeah, that's what we want to do. So we'll set it to 40. I think it's 40. And then after we set it to 40, we're going to need to loop. So maybe we have to do fill loop here, I think, because it looks wrong. And we want to store in memory address 600, comma, no, I can't store accumulator. We need to actually have the accumulator have 0 in it. So I guess in here we'll do store accumulator, or no, it's load accumulator with the number 0. It's not the number 0 because that's what the hearts are. We need to remember what the number is for space. I think it's 20. Is that right? 20 decimal. It's some number. And now in here, because that's loaded, here, let me relist it so it actually looks correct in the order. In 1330 now, we're going to store the accumulator, which has the space, into the text buffer offset by x, which is 40. Why is there 3 spaces here? That's not right. Is there a way to delete? There we go. And now we do, oh, it's 20 hex. I was close. So do I write it like this? I forget if load accumulator has, if it's going to try to load it from, yeah, I think it needs to be error. Okay, it did not like that. Well, let's assume then that it is, let's assume it's this. I just can't remember if load accumulator has a way to load off of a memory address. Yeah, right? Oh, it's the other way. It's flipped. It's just that I had it flipped, right? Oh, why does it go the other way? There we go. That makes much more sense. I didn't know the order of precedence on that. There we go. Cool. Alright, so now we've cleared it with the space, and now we want to decrement instead of decrement x, right? Is that what it is? Dec x? No, it's probably dcx. I think, let me try to remember. It was increment x, inks x. So it has to be dex? I think it's dex. That looks right to me. Yeah. And now we want to check if it's if the z bit, if the 0 flag is set. So it would be branch if not equal means it's not set. So it's equal. If it's set to 0, then we're here, right? Yeah. If it's 0, but it's not, then we want to return to subroutine, right? So I guess we'll need like a new thing. So we'll do fin loop, I guess. No. So branch if not equal to 0, we just go back to the loop. That makes a lot more sense, right? So if it's not 0, then we just keep looping. Otherwise, we know we're done, and now we can return from subroutine. Does that sound right? I think that looks right. God, no, it doesn't look right. Like, it looks all weird to me. Oh, you guys are just talking. All right. So here we go. Let us save this. And to try number 4 now. All right, so we're up to try 4. And let's try to assemble this. All right, assembly error 0. But now we have to actually call that subroutine. So that subroutine is called fill, right? Is 632. Yeah, we've got to call this subroutine fill. So before we actually open the screen and print it, when do we want to do this? Do we do this before the loop? No, we can do this. No, we have to do it before we do this loop, because if we do this after, it's too late. We're going to end up deleting everything we copied. So we have to do this before this loop. So let's do it in the very beginning, which is like 345. We will add jump subroutine, and we called it fill, right? I think that is correct. All right, cool. None of our addresses changed for starting the program. It's still 617. I'll just overwrite try number 4. No, enter. I swear to God. Try 4.source. Okay, we've assembled it, but I need to assemble the other program first. And it seems like I can't assemble this program and then the other program, like somehow the debugger doesn't work, so I'm going to do a hard reset and we'll do it in order. Max 65 420. We load the first program, which is print screen2.source. We assemble it. And then we load in our second program, which is try4.source. And we assemble that one. God, I hope you work. Command prompt. Now we do bug65. And we go 617. We got rid of some of the hearts, but not all of it. So I must be off somewhere. Yeah, hard reset, which is Shift F5 on Altera, removes everything. It's like power cycling, except without the power thing. But just if you press F5, it's a soft reset, and I think your memory's still intact. Whoops, sorry. So I should be able to do G17 again, and you see it still runs. So that's the soft reset, F5. So let's find out what's wrong with our code again. We'll compare it to what the book has. Enter D2 try4.source. Here we go. Let's look here. I think this was the one. So we have the, oops. Obj, they don't have that because this is a Mac 65 thing. 600. Oh, they start at 650. Interesting, huh? Maybe that's the problem. Maybe I'm overloading the other program. Anyway, let's keep going. They start at 650, so that's one thing to note. Then all of these numbers shouldn't matter. Text byte, I am the leader, you fool. I am the leader, dummy, comma, EOL. So it should be pretty much the same thing. I put a label here. I called it try because that's my program name. They called it response. I do some clearing, which really isn't necessary, I guess. And then load the X register with 0. We do that. Loop. Oh, they don't do the fill first. Oh, maybe they do that later. Let's see. Loop, load text, comma X. Oh, they gave text. Oh, you see, this is smart. They had this here as a label so they can do text comma X. Instead, I just had to type this 600, but their thing's way better. So let's steal that. $310 to 360. Can I do this then? Yikes. How about this? Will this work? And then I can do, it doesn't wrap around the right way. Text comma X, right? Yeah, I think that has it. Now we have text here and load text comma X. Yeah. So here we are, load. Then we do store text buff comma X. So we store the accumulator, whatever we just loaded, into text buff comma X. Same thing that I did. They do compare immediate 9B. Aha, it's that I did it wrong because you need to tell it that it's a actual number. All right. Because you see here when we compare, I'm just comparing it to this, which is $9B, but that's I guess it treats it like an address. So instead, we're going to do compare. I wonder if I can do this. You think? Maybe? Let's continue. Branch if equal, fini, increment X, jump subroutine loop, fini, jump subroutine open screen, jump subroutine print line, infinite loop, and this is my infinite loop. So we're very, very similar. We did pretty well for, we did well. They don't have the fill. I think they do the fill down here. Yeah, where they fix the heart sign. Here's the fill. So fill, load accumulator with the fill character. Okay, so this is nice. We got to remember to start using more of these like, what are they called? Constants or whatever. But the number is correct. The order here doesn't matter, I don't think. Load X with 40. Bufflen is 40, right? I think it's 40. Start, they called it start. I called it fill loop. Dex. Oh, they do dex first, then they store. Does that matter? Yeah, it does, because I'm going to copy one character too many. I did this the last time. That's pretty neat that you could do that, right? I think I switched the thing now. So now it's dex, now it's store text buff. Because before, it would have copied 40, the 40th character, but it's zero-based indexing, so you can only copy to length -1. So this is better. You'd have to decrement first, then you store it into the text buffer, and then branch if not equal, meaning that the X register is still not 0. We just keep looping. Yep. And then we return subroutine. We did pretty well. We're close. So let's store this. List D2 try. We're up to 5 now. Let's see if I can just assemble this and run it. I doubt it, but let's just see. Because every time I try this, the debugger just gets so mad at me. Hey! We did it, guys! We did it. PogChamp. PogChamp, guys. Um, so, God, okay. 54 minutes to redo what we learned last time. But I think that's how learning happens, right? Anybody have any questions on that? So yeah, I started in memory address 600, and for some reason they started at 650. I don't know if that's important. We kind of have to see like where does their open screen code sort of like end. Let's look for it. Where is it? This is their open screen code, right? Oh, and they put it at 5,000, so it's like somewhere far away. So yeah, we don't have. I think they just put in 650 for. Oh, look at. I see, because they wanted all of these programs to be able to be in memory at the same time. So the visitor was the first program. It starts at 600, and then the next program is the response to the visitor, which starts at 650. That way you can keep them all in memory. Good thing to know, but I wasn't writing the first one visitor, so it really doesn't matter. All right, let's start on this basic thing. I don't know if I'll be able to finish given that like we spent an hour already just writing our last stuff, but at least it's refreshed it, it's reinforced it. It's like Duolingo, it's like spaced, what's it called? Spaced repetition. It's like where you just basically use the Fibonacci sequence to basically try to remember something you're trying to memorize a little bit further later, a little bit more later, because then that struggle helps you, that struggling is actually good for reinforcement. Okay. So, chapter 8. Calling assembly language programs from BASIC. Sometimes it's hard to decide whether to write a program in BASIC or in assembly language. Not for me. I don't ever want to write BASIC. I don't know BASIC. I've seen the print hello world or whatever go to 10, but otherwise I don't know BASIC. But it isn't always necessary to make that choice. In many cases, you can combine the simplicity of BASIC with the speed and versatility of assembly language by simply writing assembly language routines that can be called from BASIC. In this chapter, that's what you'll be learning to do. Just like thinking about this before they even talk about it, what seems weird to me is like, how do you know where, how do you know like what memory your BASIC program's going to use? So like when you load your machine language program, your assembly program, it's going to be like, I put this in memory location 600. What if your BASIC program is doing that? I don't know. Sounds weird. Maybe it either has a different place where BASIC programs go, but that seems hard to imagine too, because like, oh, it would not go out of, but like, isn't that weird, Unlink, because you have so little memory to begin with, you know? Anyway, let's see. The first two programs we'll be working with are the ones that we were introduced in Chapter 7, the programs called the Visitor and Response. Before we can call these two programs from BASIC, however, we'll have to make a... Is there a stack on the 6502? Yes, there is a stack. Pico asked. There is a stack. In fact... Look at this right here. This is a stack command. It looks like we're going to talk about stacks soon. I don't know how they work, so we'll find out. What somebody said, I think it was in a comment, that was basically like stacks exist, but like they weren't used very much, so I don't know. But obviously you saw that we called subroutines and we came back, right? So that's kind of part of it. The first two programs, we did this already. we'll have to make a couple of changes in the way the two programs are written. First, we'll have to delete the infinite loop at the end of each program and replace it with an RTS instruction so that each program will return to BASIC when it's done. Oh my god, I'm burping. Instead of looping around endlessly, we'll also have to add a PLA instruction. I think that's like pop, or is it push load accumulator, something like that. So it probably takes something from the stack and puts it in the accumulator. Instruction at the beginning of each program so that the BASIC programs won't mess up the stack when they're called from BASIC. Later on in this chapter, we'll explain exactly why these PLA instructions are needed. If you've just finished chapter 7 and still have your computer on, you can load the visitor and response programs into your computer and make the necessary changes in them now. Alright, so what this means is we're going to have to change the memory for our try program. We'll have to put, if we want to put them at the same thing, same time, be able to run them at the same time, that is. We were at try 5, right? And we need to change this 200 here to be 650. And we don't want to, well, did they say we'll need to add a PLA instruction at the beginning of each program? Oh, I guess they tell you what to do. Where's the PLA though? Ah, here it is, 145. So right after all the bytes, you put a PLA instruction. So let's do that again. Okay, what are people saying here? Pico is saying, the calling convention is usually how you use routines without knowing addresses, but no idea for the 6502. Guess I'm gonna find out. I'm already feeling being sucked into this. Yeah, you're a Nix person, right? This is how far away are we from Nix right now. Unlink, it's really hard to work with the stack for parameters, but for calls it's perfectly fine. You can do fun stuff like push an address to the stack and then call RTS to get an indirect call on the 6502. Alright, I don't want to think about it. That hurts my brain. Alright, so let's put in the PLA. So that's right after 145. That would be right before, basically before you do stuff. It's the first command, right? So I guess we should probably change 320 to 330. All right. So let's kind of make this cleaner. 320, we'll just call it try because it'll be on its own. And then we do PLA. And then we do, we don't really need these, CLD, CLC. But I'll just keep them in because I had them before. Okay, so we have try, we've added the PLE. Now we have to get rid of the infinite loop, which is here, 530. So 530 instead is going to be an RTS, right? Anyway, I think that's right. Because this is not, this is visitor. So let's save this. Let's make sure, I guess let's save it. Now we're up to try 6. And let's try to assemble this. All right, so where we start our program is try is 667 now. So I'll update this. This is try. We start at 667 and it ends in, I don't think we need to know where it ends. We just need to know where to start it. So it's 667 for our try program. And then, and it starts in 650. We know that. Okay, and now we'll load the visitor program, which I called visitor2.source, I think. Yeah. So what we have to do here is do PLA right before. So it's 145, just like they said. PLA, right? And then, which is kind of weird, right? Because I don't think that's what it looked like from mine. Yeah. Oh. The hell? Oh, here, visitor. Oh, I have an extra semicolon. I guess I don't follow rules very well. And then what else do we need? PLA, and we need to get rid of the, we need to add an RTS. So 240 becomes RTS. Was that it? So we change 140, 245. Save it. What is this saying? Oh, they changed the comment. We don't do that. So we will save this as visitor3.source. And we will assemble this one too. 600 is where the text starts, and visitor itself is 617. So let's write that down. Where did I put the other one down? Here it is. Visitor starts at 600, but then the code starts in address 617. All right, and we have to, did I do a hard reset, or is the original code still there? Well, let's see if this works. I can't remember if I did a hard reset. Well, let's just load it. So, what is it called? Enter D2 print screen 2.source. Assemble. I should really learn how to save the binary stuff here. Well, actually I do. I just have to look at my gist, but let's see if this works. Oh, what do they say when we're done? Okay, here's visitor. Yeah, I think we have something like that. Save your amended program, right? Amending response. I think we did that too. We had to change RTS right here on 270. And they did a PLA right when we started doing it. When you've made the necessary changes in the response program, you can save it in its new version under the file names, whatever. Then we'll be ready to call both visitor program and response program from BASIC. To do that, you'll need a BASIC cartridge for your computer. If it's, oh my God, this is getting scary. I don't know how to do that. You won't need a BASIC cartridge if you have a late model Atari, since the newer Atari models have BASIC built in. Anyway, when you have your computer up and running again in BASIC now and with your data disk in your drive, the first thing you'll have to do is call up the Atari DOS menu. Well, okay, I'm scared I didn't update those files right. It's going to be so hard to do. When your BASIC interpreter's ready prompt appears, type the command DOS. All right, let's see if we can make any of this work. So, I will switch to desktop mode because I'm going to have to change some stuff here. What are you guys saying here? On link, you can do fun stuff like push. Yeah, we talked. I'm not a Nix person, but I have proposed using it for a test server at work because I want to try it. Lol. Pico, I'll let you know if I can set it up. All right. Um, so I go into desktop mode here. There you see desktop. And now I think we need to go into system, configure system. And somewhere in here it says basic. I've seen it. Here. Basic, enable basic boot without. So I think I turned this on. Controls whether internal is if enabled basic starts after, if disabled the option button. So what is the option button though? Like how do you know the option button? It doesn't matter. So now we'll do a hard reboot. And you see we're in basic, right? All right. I'm scared of basic. And it's not really the Atari basic, it's Altira's basic. I didn't get the basic ROM. Maybe I should. But hopefully it's good enough. Where were we? Anyway, when you have your computer, the first thing is type DOS. So what do we do? Type DOS? When your basic ready prompt appears, type the command DOS. Guys, I really feel like that's not going to work. Holy crap! It did work. Wow, this is Brave New World stuff here. Okay. So we're in basic, but somehow we're in DOS. I don't know what the difference is. Then when the DOS menu appears, select the menu option L. They're assuming I'm using Atari DOS, not DOS XL. That wasn't right. DOS, I thought it was called menu. Oh, this is not the full DOS thing. I don't think. God damn it. So this disk is not a full DOS disk. There's probably a way for us to do a binary load. Maybe we should do that. Maybe we should just figure this out. Let's go through the pain and heartache. Let's do this. Okay. Go back in Atari mode. So what I do, I did this. I typed in DOS. We're in XL DOS instead of the default like Atari DOS. And it wants us to type in L for binary load. But I thought we learned how to do this already. All right, we're going to have to bring up our other book, which is terrible. Like, it's scary to look at. So belt yourself, buckle up, belt yourself in. It's going to be bad. Where is this book? It's in my Atari books. DOS XL. Here we go. Oh dear God. You guys can't see anything, right? Let me see if I can just make this big for you here. Save the object to disk. Ah, okay. Thank you so much. But first, I don't even know how to load those things. So you're right. We got to do that. So let's do that. We got to do that first. Which I think means I cannot boot with basic on right now. So I'm going to turn basic off and reboot. And we have to save these in object form. So let's save all of these in object format. I just haven't done that since like a while. So let's do it. We'll first load it. The first one is called print screen2.source. We assemble it. In the assembling, it starts in 5,000. So that's where you see the codes here starts at 5,000 and it ends in 540. So 5,000 to 540, I think we have to know that so we can save this. Although it says 541, why does it do that? Oh no, that's because that's where the text comes in. It's right after the end. So it's 5,000 to 540. Uh, 5,000 is where it starts. So I think, let me look up my gist here. And how we save something. Where is it? OSA? No, that's Mac 65. B save instead of save. But we didn't write down how to. Oh, here it is. B save. Here it is. So we do B save number D, the file name print screen2.obj, and we give it the 5,000 comma the ending 5,040, right? All right, so I think we have that file. Let's take a quick look. So we have print screen2. Where's .obj? Did I save it in the wrong directory? It's the wrong drive? Oh, I saved it here. Ah, damn it. We can do it faster the second time. We load up the program, print screen2.source. We assemble it. And then we B-save it. This time in the right drive. Oh, there's probably a copy command, right? Oh, you guys aren't seeing. Oh God, sorry, I blocked it. B-save. Oh, I see you guys are saying stuff. Joaquin. The third parameter of ASM command is the name of the object file. Oh, is it? What? That's not what the book never said that. It said that do bsave minus d2 print screen 2.obj, and we give it the 5,000 comma 5,040, which tells it the beginning and end of our code. All right, So now when I go back and I do dir d2, I should see print screen 2.obj here. That's our, but you're saying that I can do ASM print screen 2.obj and it'll just assemble and save it there? That's really useful to know. So we have one of the programs ready to go. Now we will make an object version of what's it called? The visitor. And what number of visitor were we up to? Visitor 3. Let's make sure this is the right one. It has PLA and the RTS, so now we can compile this. And it starts at 600 and ends in 62B. So we're going to do B save D2 vistor3.obj and we say 600 comma 62B. We get the 62B from here. All right, so that should save that one. And now we load our last one, the try one. So we do enter D2, try, we're up to 6. We list that one, and we have the PLA, and we have the RTS here. So now we assemble it. And it starts at 650 and it ends at 68F. So we do B save D2 try 6 dot obj 650 comma 68F. And now we should have all of our object files here. We have try 6.obj, visitor 3.obj, print screen 2.obj, right? All right, so now we can try again and reboot into basic. Which means I have to set this thing again that says boot into basic. 1 second, enable basic. All right, here we are in basic. I type in DOS, and now what we need to figure out is how to do the thing where they said, let me see that. Where they said to do a binary load from DOS. I don't know the binary load command from DOS. Didn't we learn this before, though, the binary load command? Here, let me take a quick look at OSA. No, we didn't learn it. Save, run, delete file, init. No, we did not. So we're going to have to look at this. We're going to have to kind of read this other file and see if we can make sense of it. Why is it not showing me this thing? Here we go. You can see that. I can't see it on my screen actually. All right. So I'm looking for how to do a binary load in this thing. Let me see here. XL commands, copy files, load binary. Here's the load binary on page 31. I think it'll tell us the load binary. So CP equivalent load. Does that say load? Jesus Christ, I can't read that. I think so. I think it says LOA lowercase d. The load binary command allows you to read a binary file from disk into the memory of your Atari computer. This command can be used to load binary objects of assembly language programs or binary data. The file you wish to load should have previously been written to disk using a DOSXL menu save file command or equivalent method. Do not use this command to load Atari Basic or Basic XL programs into memory. Instead, just use load. To use load binary command, type L. That's not us though. You should respond with the name of the previously saved file. At this point, it will access this. So let's just try it instead of like looking it up more. What does the other file? What does the other book say here? It says type L to load these three. So let's see if we can do this load. It was called load, right? Yeah. Load print screen2.obj. That loaded it. Load visitor3.obj. Oh, it's on the wrong, it loaded this one because I saved it in the wrong file. Load visitor3.obj. Load try6.obj. All right, so we loaded all of them, right? When you have loaded, do you guys see this? It's kind of screwed now, isn't it? Because I changed the size, maybe? All right. In fact, before we continue, I just want to write this in the gist because I won't remember otherwise. This should be part of OS A. So let's find OS A. Here we go. Binary load is LOA, I think with a D, file name. Well, I'll just like kind of give an example. Load the file .obj. So binary load looks like this. All right. So assuming that was correct, let's go back to Atari roots. When you have all three programs loaded, type B to return to control to basic. Oh crap. What do you guys think? Will this possibly work? I don't think so. Oh, wait. Oh my god. So we have to figure out how to go back to basic from Atari XL DOS. All right, let's look at that scary document again. Booting to selecting menu options, backing up, entering the cartridge, entering commands, copying, erasing, go to address, load binary, protect files, quit to DOS XL. Maybe? I don't see anything here about basic and DOS. Okay. Oh, look at this. Maybe something here. Intrinsic commands, cartridge, la 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 la. Batch processing, assembly language in DOS XL, disk customizing, memory management, error, la, la. Okay. This looks like, so I'm guessing our best bet here is, what was I looking at? Maybe the cartridge stuff, 313 to cartridge. Let's take a look. Page 39. Where was, this is page. To cartridge. If you're using Atari Basic cartridge, please refer to chapter 4. Chapter 4 of this manual for information on commands which may be used from BASIC to access the disk. No, I don't think that's what. For those of you already familiar with the Atari Basic under DOS, please note, I think it's a, please note that disk access is identical under DOS XL. To use this command, select T when prompted by the menu for a command selection. At that time, you will enter the cartridge and see the familiar Ready Progress Basic. The CP equivalent is car. Should we just type car and see what happens, all right? Everyone, you're crossing your fingers. Here we go. Oh, sweet. Joaquin, is that how you say your name? You have saved us. You have saved us. You have put us on the path of the righteous. All right, let's put that in our browser for just also as we're learning all this stuff. Go to cartridge. I don't know. Back to basic, I'll just say. All right. OSA2. Back to basic car for cartridge. Okay. Let's hope that this will work. Now where's my Atari roots? All right, this takes a while. Okay, when you have all three programs, then when you're, where to say, B to return your control of your program to basic. Then when your basic interpreter is ready, prompt appears on your screen. You can type in the basic command USR 1559. We haven't done any hard resets, so should we do it? X equals USR 1559. If you've typed just away and if the object code is now stored in the memory, it should run as soon as you type and hit the carriage return, since its starting address is 1559. All right, cross your fingers, everyone. Ready? Cross your fingers. You see my fingers are crossed. 1, 2, 3. We're really close. This was really good. It ran. The problem here is somehow we didn't run the fill stuff. We've lost the clear the buffer issue. Oh, because no, this is because this was the response. This is the visitor program. We fixed, we cleared the buffer for the response program. That's why. So let's try that. That's what this thing's saying here. If you've typed and assembled your visitor program, we did that. Similarly, you can run the response. That's our try program, the one we actually fixed to this. So we'll do x equals USR 1643. This is the decimal number version of our hexadecimal address where our program starts, which was hex 617. And that said, I am the leader dummy, but then put this weird thing at the end. I must have screwed that up somehow. Let's try running it again, just in case. 1643. Yeah, so it looks like it's going in a loop also. I want to guess before I keep going. I want to kind of figure out what went wrong there, but the whole debugging thing is, yeah, is a little painful. Let's see. So we go back into, I think the problem now, I can't do this while I'm in basic, I think, right? So how do we go into DOS? Did we just type DOS? Can I do max 65 here? No, because it's like running basic, it just doesn't like. Yeah, like I basically cannot boot this computer up with basic and then run the assembly. It's just not happy. So I'm going to switch to the configuration so that it doesn't have basic on. And then we do this, then we run max 65 420. And then we got to find out where I went wrong. I think it's just the try program. So we're going to load the try program. And let's take a look at this. So 650, that looks right. The buffer looks right. This all looks right. We do the PLA. It could be that this decimal mode is screwing something up. Jump subroutine fill, right? So that's going to do the thing where we clear everything. Then we do the loop. We're going to keep looping. Then we finish. We do the open screen, print screen, return subroutine. So we're not looping infinitely here. We're returning. Here we're jumping to fill. We do this. We loop. We return to subroutine. So let's go find how that program's supposed to look and compare. Where am I? Where's my Okay, so comparing the two. We have some of these guys here. I think nothing here is special. EOL is equal to 9B, 650. I don't think it matters that it's up here versus down here. Then we have like text byte. We have that. We have the name, PLA. We can get rid of the CLD. Let's get rid of these two lines, 322, 323, and 330. 322. So now we have loop, PLA, load. Oh, hold on. I'm jumping to fill after I do this. That seems kind of bad because I'm kind of setting the, I don't really know if the X, yeah, I don't want to do this. Let's change 340. You see here that like I'm setting the X register to 0, but then I go off and do stuff. It really shouldn't be that way, right? It should be the other way. Because what if this subroutine changes the X register? So, where are we now? We're at 0. We loop, we load the text buffer, compare. This could be maybe a little different. Notice how we do this thing, but I don't think that's the issue. Increment X, jump loop, fini, jump subroutine, return subroutine. Then we have fill, 40. Don't think it matters that these two are different orders because they don't affect each other. Fill loop, dex, store, x, fill loop. That's the same as start, return. So otherwise it's the same. So let's save this now as a new version. D8, what am I thinking? So we're up to try 7.source, right? And now let's compile it. And it ends in 38C. Is that any different? I think so. Where did I write this down last time? Anyway, I'll write it down here. This ends at 68C. And it starts at 682. Let me make sure that's right. 650 is where the data goes, and then the code starts, oh, it starts in 667. Whoops. It starts at 667 and ends in 68C. So now I can do B save, D2, try, what are we up to, 7.obj less than 667 comma 68C. Oh, no. We need to save the data too, right? So it should be at 650, shouldn't it? Yeah, it should be. 650. Otherwise, it won't have the data. It has to be 650. Yeah, we had to store where it starts because that's where we wanted to start executing. But here we want the beginning of the program data. So I think we put 650 comma 68C. All right. So let's try, I want to actually try running, let's try running this now in BASIC and see what happens. So I have to reset the computer to boot up in BASIC. Oh, this is such a pain. Here we go. Now we do DOS, and I can look at D2, and we see that there's a try7.obj. We have to load all of them. Print do I need a thing here? No, right? D2 print screen 2.obj. And I don't think I need the other one. We just can load, because we're only checking out this try one, try7.obj. And now I can do x equals user, and what was the line number for this? 1643. Oh, I gotta be in basic. Car. X equals user 1643. So it copied it, but it's not clearing it. Am I clearing it and then doing this? Am I clearing it at the wrong time? Do you guys see anything? Ah, crap. I typed in, I pressed F5 by accident when I meant F8. That is a really bad habit. Okay, maybe I'm calling it, first I fill, and then I do the loop. Right, that's correct. I fill it. And then I do the loop. And the fill is filling it. So we had an issue here where compared to our code in the book, this was reversed. I can't imagine that would make any difference. Loading the accumulator first might affect the X register. No, it wouldn't, right? It just doesn't make any sense. I don't see anything else wrong. What was the other thing? The other thing we didn't see was here they want, in the code it said 9b. Like instead of using the constant. So maybe we try this. Now it's like, it should be exactly as the code in the book now. At least, you know, the idea of it. This is, okay, so this could be changed a little bit too, but I don't think that's it. We're getting close to being the same thing. Try, PLA, jump subroutine fill, LDX, loop, load, text, store, CMP, branch equal, increment X, jump loop, fini, jump subroutine, open screen, jump print line, RTS, fill, LDA, character 20, start, decrement store x BNE start RTS. So now it's like pretty much the same. So let's save this one more time. Try, we're up to 7, 8. And we can do a B save also. Do we assemble this? Okay. Say, what's it called? B save. Try 8.obj 650 comma 68C. Okay. So now we go back, and in D2 we have try 8obj. Should be okay. Let's try one more time. One more time with feeling. Oh, I'm starting to get beat up by this thing. We'll turn on basic. Do a reboot. We're in basic. We go to DOS. We can look at the directory. So now we can do a load. D2 print screen 2.obj. We can do a load D2 try 8.obj, and then we go into basic again, and now we type in x equals USR, what was the number again? 1643. I don't know. I really don't know what's going on here. The only thing I can think of is I think you can set breakpoints in Bug65. I just don't know how. But I think what I would do to help like debug this thing is actually like try running it outside of basic and just make sure it still works. Maybe because maybe it basically stopped working. Or maybe we're running into incompatibility with basic here. That'd be so annoying, right? So let's just try going back to the other version. Here I'm running it without basic now. So I can do max 65 420. I can load that program. Actually, let me load, I guess I can load print screen 2 dot. No, I think I can do, is it bload? I think we can load directly the binary and do print screen 2 dot obj. And now we don't have to compile and everything like that. And then let's do the enter D2 try 8.source. And if we want to go back to the old version, we get, oh wait, why do I have 2 tries? Wait, oh, that was did you see 2 tries there for a second? Seemed weird. The other thing I could do is move this down like they had, because they had it. Well, let's change one thing at a time. Let's go back to a non-basic version. So we have to get rid of 321. So we get rid of 321, right? And we get rid of we add back the infinite loop, which is here, 530. So we can say 530 is loop forever. Loop forever, jump loop forever. There we go. And this we will call, this should be the version that, I think those were the only two things we changed, right? So now we're kind of looping forever here. And we should be okay. So I'm going to save this version. Let's try to compile it, make sure it compiles. And now notice it's up to 68. Try 9 is going to be 650 to 68D. Right. And now we can do B saves. Try 9 dot. Well, we should save. I don't think I saved the source. So let's save the source to try 9 dot source. And we can do a B save. Try 9 dot obj 650 comma 68D. All right. And Pico asks, are the two modes assembly basic of booting something built into Atari? I think if it were a real Atari machine, basic would be like, it used to be a cartridge that you would have in the machine, but with later Ataris, like it would be built into the ROM. And so it's like I think it depended whether or not you held a specific key down while it was booting. If it was booting one way, it would boot into DOS, and if you held a key down or not, it would boot into the other thing, basic. But I don't know which is which, since I don't have a real Atari. Where were we? We're going to try to run this thing now, right? So it's compiled, it's in memory. So now I should be able to go into debugger. So we'll go back here, bug 65. And then run, oh crap, I don't know what the first starting line number is. It's probably still 667, isn't it? So look at this. This one worked, right? I didn't change anything, but notice like it cleared the memory. I actually think that there is a problem with basic. I can't think of anything else. Or like there is some problem in our code, but it only shows up when we're doing it the other way. This doesn't make sense. Maybe I should get the basic ROM, huh? Should we look for it? Hey JJJ, Atari is going well. We got this program, but we're kind of stuck because trying to run our program from basic sort of causes like a weird artifact. And I don't know why it's doing that. Is it polluting the buffers after your code runs? Like how could it? That's the whole idea of returning from subroutine. You know what I mean? Like you mean it prints it out and then it changes the screen values? No, that doesn't make sense. That doesn't make sense. But yeah, Pico, if it's like something that people could benefit from seeing in the stream, I don't have Discord going in there. So if it's like Discord's great if it's like, hey, I want to say something and it's really now, like, yeah. But otherwise, I think it's okay on the stream. Then other people can see and I don't have to be like, oh, the invisible Pico. Or I can figure out how to like maybe add Discord into the chat on the screen. I'll figure that out maybe. We can write a program. Yeah, let's look for an Atari ROM. Do I have one already? Atari ROMs. OS ROMs. Mac 65. I don't think I have Basic, so we're gonna have to look for Atari Basic. Cartridge. Instructions. Download dump. Do you think this is it? Alright, so I have a cartridge now. I don't know if it'll work. You see, like, I downloaded this link from Atari Mania, and I have Basic cartridge. So I'm going to put this in my Atari directory. And where's the Basic cartridge? Here it goes, but this should go into ROMs. And now we have Basic cartridge in our ROMs directory. Let's figure out how to tell this guy to use it. Enable basic, Altera basic. So what does this do? Kernel, game, kernel. Oh my god, what is all this? Where's basic? This is where we are, I think. So I think we can add something. Oh, it's not seeing it. Alright, so that's not it. Let's try something else. Let's put it in the cartridge. Somewhere in here is cartridge. Attach cartridge. Basic cartridge. Now I'll do a hard reset. So I think I'm in basic. How do I know if I'm in basic? This is all I know. Hey, okay. So we're in basic. So we are using a real Atari basic cartridge now. Let's see if we can run our program the way they were saying to do it. Which means we can, oh, here's Pico. JJJ, I wish I could help, but I'm clueless how to program for Atari stuff. Me too, join the club, JJJ, don't worry. We're all clueless here. Well, some of us more than others. Pico, in the version you call from basic, I wonder what would happen if you just loop forever at the end of your code? Yeah, it's a good question, right? That's a really good question. But we're on this path now. It's a really good like way of thinking though. I commend you for that because you can kind of figure out like, is it basic fucking it up or is it like something our program's not doing? You know, is it after return is being returned? Control is being returned, right? So it's a good way of doing it. Okay, so I have basic, which means I should be able to type DOS. I'm back in DOS. I should be able to load these programs now. d2 print screen dot 2 dot obj, right? And I can load d2 try, and we don't want 9. 9 is the one that loops forever. Well, let's try number 8. And then we go back into basic, which is car. I'll get that in a second, Joaquin. Car, and now we should be able to type x equals user. What was the thing? 1643. Error 9. Okay, so two things going on. One, Joaquin asked, what is the PLA for in line 145? Basically, before our code starts, it's trying to set up the stack so that when basic's going to call into our program, this is going to put the stack, basically set the stack, push onto the stack, I guess. And then when we're done with the program and we return to basic, it'll be able to pop from the stack. So that's in the return from subroutine here, I assume. But that's what we're learning about right now, is this whole stack thing. So they told us to put it in there. But yeah, look, it's like still an error, but notice we don't like hang, right? Let's ask Google what error 9 is in Atari. Oh, basic ROM? Okay. Something wrong with the size of our thing. What the heck? Maybe it wasn't an Atari error, you know? Maybe it's not basic. But maybe it is. I guess it is. So somewhere we're overrunning the buffer or something like that. Okay. The other thing is Joaquin said, what if we run the other program? I want to know that too. So let's try that. So we have to go back into DOS. We load, I don't think we need to reload the first program. We just need to reload the second program, which is try, and we do try 9, which is going to loop forever, but it doesn't do the PLA. So it's okay though, because it loops forever. So let's see what happens. Didn't I save it? Try 9 obj? What did I type wrong there? Load D2. I don't know. There we go. I probably put a hash or something in there. And now we go back to basic. And what was it? 1643 was it? X equals user 1643. I have no idea what's wrong. It's not even calling the fill. Do you notice how like it's hearts here? So it means it's not calling the fill. Do you think maybe the print screen program was saved to binary wrong? Maybe it's the print screen program. Let's revisit that for a second. So we'll do detach cartridge. I won't go into binary mode for that, but basically, I mean desktop mode. We'll detach the cartridge for a second, and let's take a look at print screen, because maybe I just saved it wrong. That was load. Print screen to dot source. And look, we start in 5,000. Bufflen is 40. Interesting. And we end in 660. So when we assemble this, what's this thing for? Plus Bufflen. I don't remember writing that, but maybe that's how they wrote it, because we didn't write this program. Here it is. Yeah, that's how they wrote it. Okay. When we assemble this, it starts in 5,000 and ends in 5,000. Whoa. 5,000 what? It starts in 5,000 here and ends in 540. But look, there's stuff here up to 5,069, right? So maybe I'm missing stuff. Maybe I just didn't save the binary right. 5,000 to 5,069. It starts in 5,000. So these are literals. These are constants. We don't have to worry about that. So why don't I save more of the memory? Let's do that. Binary save, print screen. We'll call this one 3. Dot obj. And that was 5,000 to, what was it? Did I write it down? 5,000. Did I say 60? God damn it. I didn't write it down. Does anyone remember? I have short-term memory. Help! $5,040, and then we saw 5,069. All right. Because this is another part of the program. I'm not sure what that's doing, but let's assume that we might need up to 5,069. So we do bsave print screen to 3 dot obj 5,000 to 5,069. Bsave d2 print screen 3 dot obj 5,000 comma 5,069. Let's also print this source in there too. Even though it's the same, I just want to keep the numbers the same. Print screen 3 dot source. All right. So maybe this is it. Let's try it again. So we should boot with the cartridge on this time. I'm turning on the cartridge. Attach cartridge. All right, so now we're in basic. Let me do a hard reset. And then I go into DOS and I load D2, what was it called? Print screen3.obj. We don't need the hash. I wish this was a little more consistent, you know? And then we also load our program, which is try. Should we load try 8? That's the one that should work, right? Try 8. Try 9 is the one where we loop forever again. So let's try 8. Let's go big, go bold. And then we go back into basic through the cartridge. And then we do x equals user 1643. I'm going to kill somebody. What if we do load d2 try9.obj? Nope. I'm like really out of ideas here. Hearts are 0, right? Yeah, it's 0. So it means that it's not going through our fill code. Is it even running our code? Should we check? Should we just change this print message real quick? You know, like, I don't even know what code it's running anymore. Let's also move 200 down to where they have it. They moved it to not this code. Is this it? Visitor. What's really funny is visitor works, right? Like, but our response doesn't work. How weird is that? So the difference is that they have the starting right before text. So let's move this 200 to right before text. So 200 will go to 200 will go right before. So it goes at like, I guess it can go at 305. So now 200 is gone. And we have 305 where we have this address. EOL is 9B. You know, when it says like error 9, like overflow, maybe it's just like never reaching this comparing to 9B. Doesn't make sense, right? Because it stops, otherwise those hearts, I don't know. They do it the same way here, right? EOL, EOL. So what was I saying? All right, let's just try changing the message or something and seeing if at least it's running our program, because this is really weird. Here's the fill loop. Fill. are we, it seems like it's not calling fill because it's not clearing the stuff. So where are we calling fill? Here, we're calling fill in 340. Right here, right after, yeah, right here. Same thing as this. So our code starts. Text try is the code name. That's the same as this. No, that's the same as this. PLA jump subroutine fill LDX 0. Yeah, and fill is down here somewhere. So it should be doing that. Load LDA fill character, and fill character is number sign hexadecimal 20. So it's number sign hexadecimal 20 is what we have. Then LDX number sign bufflen, and bufflen is 40, so it's number 40. It's the same thing. Start decrement X, store text buff X, branch not equal fill loop. That's the same as start, return from subroutine. Anyone, let's just change the words a little bit and make sure at least we're running our program. 310. I am the leader, comma, you fool, is what they have, with exclamation, with an EOL. What? Oh, dot type, dot byte. I think I can just go back up and change this. All right, so at least it should say this now, right? All right. So this is try number 10. Try 10 goes from 650 to 690, right? 690 is the return. And the start, oh, let's make sure that we're starting in the right place. Wouldn't it be funny if we're calling start in the wrong place? So try is 66B. B to decimal. Well, just give me the answer. 1643, that's what we've been doing, right? Yeah, so that's what we've been doing. Yep, 1643. 1643. So we're doing the right start address. Let's save this as try number 10. $650, comma 690, right? Yeah. All right. So what did we change in this one? We changed the words. So let's make sure we see the new words at the very least. We're going to reboot with basic now. All right, so we go to DOS. We load D2 print screen 3 dot obj. We load D2 try 10 dot obj, right? We're up to 10 now. And now we go back into the cartridge and we do x equals user 1643. What the fuck? Guys, how could this possibly be working and I didn't change anything? All right, sorry, I missed some chat. I'm really sorry. Yeah, so hearts are 0, right, in a ASCII, and 20 hexadecimal space. Pico, is there enough space for the text literal in the code storage? Don't they leave some space in the example? Are you saying my string was longer? What did I have? Let's go check, because maybe you're right. Maybe. Let's go check. We can check. You're probably right. I think you're right. I just never checked whether my string was too long. All right, so let's do this. We gotta load back into without the cartridge, so we detach the cartridge and we go into Mac Assembler and then we load it, and we need to load try 9, the previous one, before we changed it. I am the leader, dummy. No, mine's shorter because the one that we typed that worked was I am the leader, you fool. Right? Like, my string is shorter. I am the leader, dummy. Wait a minute. Wait a minute. Wait a minute. Wait a minute. You know what I think it is? I think that we were using the wrong number for the start because it's shorter. We just used 1643, but try here is not going to be 1643 because it's a shorter string. You see what I mean? All right, so let's test this out. So try 8. This is try 8. When I assemble try 8, we have to look for this symbol, this label. It's called try. And you see try is 667. That's not what it was before, right? I don't understand. 1 second. Because before we're doing 66B, but now we're doing 667. Which would be 1639. So what I think is if I use 1639 instead, it'll work. Let's go test this out. Let me read what you guys said first before I go off on my thing. I saw they left some space in the example with just semicolon. The semicolon are remarks. They're like comments. So those don't compile to anything. They're only for source code. I don't know where the Atari stores text literals. Does not have a separate code and data space. It stores it right here. So since it says it's starting at 650 in memory, this text byte is going to be literals starting at 650. And so what this means is what I'm saying is that if you change this size, it's going to change the starting address of this. And this is the label we use to actually start the program. So they, in the book, hard-coded it for like their exact string. But we have to look for our label and use that value instead. Okay, and Slinky Dink says, you're missing buffer length around 210. What do you mean 210? Here? Or do you mean something else? So let's try this thing out because I think this is what the issue is. It's a good learning example. Hopefully we're right. So, yeah. I think I have everything I need to actually run this. So I just need to use a different value. So let's put the cartridge back in. All right, we got the cartridge back in. We're going to load our print screen. We'll load the latest one. And then we'll load try number 8. And then we'll go into cartridge, and then we do x equals user. And what was the number again? It was 1639 instead. Guys! Oh my god! That was it! Line 210 of your code. Oh, let me look at just to see what that is. But I'm so happy. This was it. This was it. You know how long we've been at this? 2 hours and 37 minutes. For these, that was the whole thing. But I don't know how long we were stuck on this one thing, but we figured it out. Like, when you're programming in a high-level language, you don't think changing a string is going to affect how you run the program, right? It's just like, it's just not how you think about it. Yes, exactly, Joaquin. That's exactly it. Every time you change the text, it's going to change the subsequent addresses, right? So, God, who thinks of that? Like, this is a new mindset for me to try to remember that, like, hey, each time. So, yeah, how can you make it? One thing you could do is put the buffer later in the program, right? Like, have your, like, can you imagine over here? We just have a jump command. Like, if we put a jump, well, why don't we fucking do this now? We'll just do this. We got to get rid of the basic program thing again. God, what a pain. I'm starting to think it's better to learn how to do this through Visual Studio and just upload it. But like, yeah, but we're getting the full experience. Yeah, I think I know what you mean, Pico. What I'm saying is, if we load this program, how do we do that? Enter try8.source. That was our latest one, right? What did we do in the other ones? I don't even remember. Oh, we just changed the text. So here you see like we're changing the length of this thing, right? Which then ends up changing this value. So how can we make it easier so that this doesn't keep changing? So what I was thinking was we're starting in 650 here, right? So if we actually make something in the very first line after 300 that jumps to try, then we don't care about this stuff. You see what I mean? So let's put in a 301 jump try. We'll call this try 0 because it's like the alpha try label. We'll call it try 0. And it just does jump try. Or you can put it at the end, right? But here's one way we can just kind of like really easily change this program, I think, right? So now we have try 0, that's going to jump to try, and then it has all of this in here, right? And our program's going to start in 650 no matter what. So let's try to compile this. Let's save this. List D2 try. We're up to try, what is this, 11, I think. I think we're at try 11. Try 11.source. And then we'll compile it. And we can see that like our code now, try 0, starts at 650, right? And this is the jump command. And the last one is 68F. So now it's 650 to 68F. Try 11. Hi, sweetheart. Try 0, 650, and the last one was 68F. So now we do bsave try 11.obj 650 comma 68F. Oh, whoops. All right, so now we have that in there. So we should be able to load this. And now we can use 650 as our, I'm going to be done in just like, yeah, I'll be done in just a minute. We're going to get rid of, we're going to add the cartridge. Now we go into DOS, and then we're going to load. It's so hard to remember everything. Print screen 2, right? No, we're into, oh crap. Load print. I'm falling apart here. 3.obj. I'm really falling. It's a good thing this stream is ending because you can see I am falling apart. And then we do disk2 try 11.obj, right? We're up to 11. I think we're up to 11. I can't remember. And now I go back into the cartridge, and now I do x equals user. Does someone have the what's the equivalent of 650 in decimal? I think it's okay. 1616. That works. Or we could move it in the very end, just like Joaquin said. Anyway, you guys are really awesome. I actually had a lot of fun interacting with everyone today. Thank you, Slinky Dank. I think we're gonna call it here. This was painful. Good learnings though, really good learnings. So next time we will be doing understanding Python interpreter. Yeah, good point. The user function, like what this was about. And how much more do we got? All right, we got quite a bit of stuff, but it'll be fun. This was painful, but very fun at the same time because we figured it out. Can you imagine if we did all this and we like just gave up and we had no idea? It was like these things are just within the like perseverance threshold. Like if you just persevere enough, like looking at these old manuals, it's like being an archaeologist and trying to figure it out. We can just do enough. We have just enough capacity, capability to like, and competency to like figure it out together. Thanks, everyone. We'll be doing some more Atari again, but before we do that, I'll be looking again at Nick's and what else are we doing? I forget, like the other stuff, Take care, everyone. Go look at, if you're interested in more of the Atari stuff, you're like, oh, I want to do it on YouTube in my channel. It has an Atari playlist, and you can kind of go from the very beginning, the first video, and go through. And it's like when I started, I knew zero. So the stream is going to be up on YouTube, so you can always look at it. And then when I finish a chapter, I make a full video out of it. So, I kind of cut the streams together so you have one whole chapter of the book together. All right, take care, everyone. Hi, Sydney. Sorry we're leaving at the as soon as you join. I'll talk to you all later.